Welcome to this subject, ma. This is a MFE subject. What I am going to teach here. Uh, the metal forming process. So, what is the metal forming process? Means here we have taken some questions, ma. Here I would like to explain. I have taken some questions here. Some 10 questions I have taken. Important questions I have taken. 10 important questions where I want to discuss about that. The first question is explain in detail the steps involved in making a casting and discuss its advantages and applications. See, one short question to explain about casting. So, its disadvantages and applications also. So, here casting is a fundamental manufacturing process. So, what is happening, ma? This is the basic thing. It is the oldest thing, but involves pouring molten metal. So, you have to pour the molten metal into a prepared mold cavity. So, already mold cavity is there. So, here directly I'm going to the diagram. Here you can see this is the basin. Here, sorry, here the basin is here. From this basin, this is called as basin. This pipe is called as spur, and this is you are having directly the metal is coming here into this cavity. This cavity it is taking the shape of this mold. Okay, this is the mold cavity you can see. So this upper part of this portion is called as cope, and the down part is dragma. So both are joined together, and this is a flask, and there is everything sand here because sand is absorbing of heat. So this is a parting line. This is sand is there here. The molten metal what you are pouring, it will come, it will go rises here. Some riser is provided. Again, riser is provided here. So normally it will go here. It will settle into this mold cavity. If any extra metal you want to pour it, you can pour from this open riser because the metal, molten metal coming from this spur and this riser solidifies. Means as the temperature increases, the liquid metal becomes solid. So there is no way that extra metal come and settle here. If some we need to make some extra passage. Extra passage is called as riser, from where you can pour the metal and you can get a perfect cavity. So here casting, this is a prepared mold cavity shaped by a pattern. It solidifies into desired shape. Whatever the shape you want, it will be desired to that shape. It will take that shape. Often complex. So very complex shapes which you cannot draw by your hand. Then you are going to cast them. Examples: components of automobiles. Final shape. So final shape is the what you want. The process includes pattern, mold making, metal melting, pouring, cooling, and finishing. So the process includes first you need to make a pattern. This is the pattern you are going to keep. Then metal melting, you will melt the metal, you will pour here. The pouring, after pouring, cooling should be there. After that, you will break this metal, you will remove it. It is widely used to create the intricate, durable, and large components. Big components, for example, wings of aeroplanes, body cavity of cars, engines like this. Components such as engine blocks. Engine blocks we can make from varied materials like iron. The metal can be iron here, steel, aluminum, offering high design freedom and low cost. So this is a low cost way of manufacturing a big item or big component. Okay, so this is called as casting. So it is a casting. What is the casting elements means you can tell it is flask, it is scope, drag, open riser, vent, pouring basin. All this you can tell. Sand is used here. So if I am not wrong, I'm going to take the second question. Describe, explain, describe the pattern making in the casting. So what is the pattern making in casting? So this is the pattern making. This is the pattern which you want to make here. Pattern making. So explain various types of patterns. So these patterns can be made with wood, steel, plastic, iron, etc., etc. So we'll see that one. Okay. First, I will read the theory. The pattern making is essential first step in casting. So pattern makings are very essential. Where is a replica? It is a replica means it is a shape of that of the designed metal object, usually made up of wood. In olden days, wood was cheaply available wood was used. After that, they started using metals. After the metal is, you can use 2 to 3 times. Plastic also you can use one time only. Once you have to break the plastic, you have to take wood also. You have to break it, but metal you can use it multiple times. It is created to form the mold cavity. It is slightly larger than the final part to account for metal shrinkage and meshing allowances. Okay. Types of patterns in the castings. What is the types of patterns in the casting? Different patterns are used based upon the casting complexity, production volume and sizes. So simple single metal piece. So single metal piece for wood is a single, plastic single. Split patterns means you can open like box you can like box upside you call cope, downside you call wound, and you can clip it like that. Split into 2 parts cope and lag along the parting line to facilitate removal from the mold for more complex shapes. So more complex shapes means you are going to use split pattern. Otherwise, you are going to use split. So here you can see types of patterns So this is one type of pattern above and down. Here also some patterns, skeleton type patterns can be used. And also you are having so these are all the patterns where these types of castings are used. So here it is called as pattern This T shape is called as pattern, which is kept inside this. And this is totally mold cavity So this pattern is kept here in the mold cavity. So this is the shape mold cavity. This glass molding sand is used. So these are the types of this one. So third question we are going to take. Explain the principle of gating system. So gating system is here. You can see in the diagram. Here these gates are provided. This gates is like a spur base. After liquid traveling from the spur, coming into gates. Here one gate, two gate, three gate. So this is the opening for the casting. Metal flows from these gates into the casting area in order to solidify. And they are designed with suitable diagrams. So you have to show. Here in the diagram, it is shown here. This is a runner, this is a choke, this is a spur, this is a pouring basin, riser, and these are the in gates. So in gates, these are the in gates. So this is the gates. The in gate system, pouring basin, spur, runner gates, and riser design ensure sound castings. So you'll get a good casting by directing material without turbulence. So no turbulence should be there and compensating for shrinkages. So it will come shrinkage. Key principles include minimizing turbulences, smooth path, preventing aspirations, tapered screw, trapping insulations, runner extension, and ensuring the directional solidification towards the riser. So the goal is to fill the cavity completely. So why these gates are used means different ways it will go. From here it will go upper part, middle part, and last part. Different ways the metal flows and goes and settles. So minimizing the defects. No defects will be there in the gate system. Very less defects like erosion, trapped gases. So mainly trapped gases is a problem that has to go out. So if I'm not wrong, next question, my fourth question. Discuss solidifications of castings. So how a casting gets solidified? Solidification means becoming solid from liquid. Explain various casting defects. So what are the various casting defects, causes and remedies? If a cause is there, we have to take some action. Remedy should be there. Here you can see here solidification of casting. In the diagram you can see here we can show this is called as a macro porosity. Some porosities due to air they are more. Here you can see closed shrinkage effects. This is a open shrinkage effect. So this is a open This is closed inside. This is a pipe. Curved surfaces are formed here. Here also line Some line is not properly filled here. Here not filled. Here not filled. So here also you have micro shrinkages. This is macro, little bit big. So inside and outside. So here as per the definition, these are the solidification problems. Solidification of casting involves the cooling and phase transformation of molten metal within a mold. Transitions from liquid to solid through nucleation and crystal growth. So what happens, liquid will become solid. So it is a cooling phase. It is a phase transformation. What phase transformation? Cooling transformation. So what is there? Crystal growth will take place. It begins at the mold walls only. This is the mold walls. This is the mold walls, forming solid shells that grows inwards with total solidification time governed by volume and surface areas. So this is also explained by Chevron's law. So the solidification was explained by one of the scientists, Chevron's law also. So if I'm not wrong, next question I'm taking, ma'am. Explain centrifugal casting process. So you need to explain about centrifugal casting process. So what are the advantages, limitations, and applications? So centrifugal means, see ma, this is the centrifugal ma. The rotation type is called as centrifugal. Here, here also you can see ma. This is a semi-centrifugal casting process. Okay, here you can see this is ma. This is a very ladle is given. It is poured ma. This is coming inside. This is a mold cavity. Okay, now this will rotate ma. See, rotating rollers are there. This is a continuously rotate ma circle. So while rotating, what happens ma? Centrifugal force develops inside. So it will take total the mold shape. So this is you can get rotating shaft ma. This is rotating motor is there. So this will rotate ma. Round and round and round. This will rotate. So centrifugal force is developed inside ma. Whatever the density, high density material will go and settle at this walls, and in the center you will get a fine material. So this is a way of central here also ma. It will rotate. It will rotate ma. Here you are going to put the ladle ma. You will pour here. So this will rotate ma. Centrifugal. Rotating. What happens? It will take the shape of this mold. This is also. Okay. So here also ma, this is the core ma. You can see this ladle will taking this one and the motor is man. This will rotate ma. This will rotate in a horizontal way. So this is a x-axis, this is y-axis rotation. So here motor is there ma. From down it will rotate, and totally the metal will settle inside the core. Okay. That force, centrifugal force is used. So it is called as centrifugal. Once I will read the definition ma. Centrifugal casting is the manufacturing process. One of the manufacturing process you can tell that pours metal into a rapidly spinning mold. So definitely spinning will be there ma. By using a motor, you have to spin the mold cavity using centrifugal force. Automatically, centrifugal force is developed inside to distribute metal against the mold walls for solidification. So mold walls, no defects in the walls ma. Total, the metal will spread up to the walls in a fine way. It produces high density, high strength, hollow cylindrical parts with excellent grain structures, often without needing cores. So no core is used. Automatically it will spread here because spinning is there. Make it ideal for pipes, tubes and brushes. So types, what pipes are made ma? Here tubes are made, bushings are made. So bushings which are used in the automotive components, bushings can be made. The next question I am taking ma, describe the die casting process in details and compare it with the sand casting. So what is the die casting process? So die casting is also one of the manufacturing process ma. Here you can see die casting versus sand casting ma. Okay, here die casting is there. So you are going to use a die ma here. This is a die. Inside the die, okay, you are injecting this metal here. Okay, so from here, the high pressure and precision parts are developed here. So let us take the definition. Die casting is a high pressure manufacturing process using permanent steel molds or dies. So steel mold or dies are used here. No wood, no plastic. Permanent it will become to produce complex, thin-walled, non-ferrous metal parts also used. High dimensional accuracy, superior, super surface finish. You will get a good finish. The process involves injecting molten metal, for example, aluminum parts, or you can make zinc parts into die, rapidly cool it and inject it in the 30 to 90 seconds per cycle, making it ideal for mass production. So you are going to inject ma. Here we are pouring sand. This is a manual one, coarse finish. Here precision parts ma. These parts are held by this die ma. So they are injecting this one. So die casting this is. The dies are used here to hold this workpiece. Aluminum or zinc is poured here, injected into this. Here, 30 to 90 seconds per cycle it can be producing. Next question we are going to take. Explain investing casting process with a need sketches and applications. So investment casting is also a one of the casting process like centrifugal casting or die casting. Ma. So here you can see investment casting. So here this is runner ma, this is gates, this is the metal casting. So here where the metal has to be cast here, settled here. So ladle is used for pouring the molten metal from this one. So this is investment casting. So one, two, three parts at a time. Four investments are done. Four products are produced. So this is called as investment product. The investment casting or lost wax casting, which creates complex, high precision metal parts by creating a sacrificial wax pattern. So this is going to create a sacrificial wax pattern that is coated in ceramic to form a model. So it is used for the ceramic to form a model. Molten metal is poured into this hardened hollow mold, enabling exceptional surface finishes. So whatever the is molten metal very hard and also a hollow shaft here. It will become hollow mold, enabling expressional surface finishes, good surface finish, tight tolerances, intricate geometries in various alloys are used. So you need a tight holding is there because this is SIMA, this is tightly hold. So it is investment casting. So what is this is wax pattern is used, wax tree assembly. A precision wax replica of the final part is produced by the injecting wax into a metal die. So you can inject metal into this with force it will go and settle in all the ways. Wax tree. Several wax patterns are attached to a central wax stick, runner and spur to form a tree for casting multiple parts at once. So tree type means you can see here also tree type It is having branches. This is the way also you can do mass production. Okay. Next question I'm going to take shell molding. Shell molding is also one of the molding process which should be known to the engineering students because in common used in the industries commonly asked for interview questions also. So here you can see this is the molding process advantages, limitations and applications Here the shell molding you can see here step 1, step 2, step 3 and step 4 You can see here also one it is shown shell molding shell type. So this is a shell type mold which is kept inside means this is shell type mold which is kept inside flask. It is clamped here. Okay, first let us take the definition Shell molding is an accurate metal casting process using a heated metal. So heat you are going to heat the metal pattern covered by a sand resin mixture to form a thin hardened shell. So it will form a hardened shell. It provides excellent surface finishes. It will give you a surface excellent finishes, high dimensional tolerances, and fast automated production for complexes. So automated production for complexes, small to medium parts. So big, small to medium parts is ideal for high precision components like automotive gears and valve bodies. So automotive gears and valve bodies are used here. Okay, so gears you can valve bodies here you can produce. You can say yes here angles are used here. It is a pattern which is kept here pattern. Okay, this is a pattern. This is the sand inside this one. Okay, this is the pattern first one. Then in the step 2 you can see it is reversed. It is reversed. So sand is coming on the pattern This is the hot pattern. This pattern is sand is poured. After that again in the third step it is reversed again normal position. So after that it is taken out of this one. So you will get the intricate shape pattern what you want. So here also it is there inside So metal is poured. Always here side sand it is there. So once this flask is removed, sand is removed, you'll get a shell here. What is that? So this is the shell molding. So last question I think this is yes last question. Compare between centrifugal casting comparison take So investment casting is there, and also die casting is there, centrifugal casting. Three are there. So what is there? Single use ceramics. Only ceramics are used here. Permanent steel dies are used here. Permanent metals are used here for the mold type. So what is the mold type you are making is steel ma. Here also you are using metal or graphite. Here ceramics are used investment because round and round rotation here. In the die casting you can see die it is injected ma. In the centrifugal it is rotated. So high complexity here also high speed, high density. Small to medium shapes ma, very small or medium. Here small, medium, ferrous. Here you can see cylindrical hollow parts are done. Here ferrous and non-ferrous. Here only non-ferrous ma. Here ferrous and non-ferrous. So it is superior quality in the instrument casting, moderate quality in the die casting, good it is. So this is the comparison table. Any two or three you have to remember ma. So here you can see ma centrifugal casting. I have already said ma. This motor is there. This is going to rotate this one round and round ma. After once the molten is poured, it will be rotated round and round. Again, then if some extra we need, we again will pour, will rotate. In this way, central mode. So I think one more question is left for Yama. Explain casting designs considerations for producing defect-free casting. No defects. So what is the defects means types of casting defects we can see ma. So here in the center you are having air gaps. Here you are having small air gaps. Okay, here corners you can see ma. These are all the defects ma. Here shrinkage is there. So different of defects you can see. Defect-free casting design requires maximum simplicity. So the pattern should be simple, ensuring uniform wall thickness. So all the wall thickness should be uniform. One side heavy, one side low. It will be not a proper way. To prevent shrinkages, hot tears, incorporating generous fillets to reduce the stress concentration. If this is increasing the stress concentration at the walls also. So be careful. The wall defect should be low, including proper defect angles for easy removal. It should be easy. Draft angle should be there, man. So draft angle is easy to remove. Otherwise, difficult to move. It will disturb the pattern. So the key factors include maintaining consistency cross sections. So area should be maintained cross section. Optimizing gating systems. So gating system should be perfect. Optimized to minimum turbulence. So turbulence should not be there. Minimum turbulence should be there. Laminar flow should be there. Ensuring proper ventilation. So full air flow should be there. So you can see this is also one of the type of defect. Here see high over material, low material. So everything, all the types of defects should be this one ma. So I think I have covered almost all the important topics in this first unit ma. That is casting process. I think it will help you in your studies. So see these videos, share these videos if possible, like ma and forward to your friends. If any suggestions are there, please give in the comment box. I will be updating in my next videos.